Welcome back all the fans and followers of space fiction. I went to see the neighbors on Alpha Centauri and got stuck in a cryosleep on the way. And what seemed to me to be just a short moment was a few months for you. But now I'm back and I can give you a few reasons why galaxies don't need dark matter to explain their rotation. Irregularities in the rotation of stars around the galaxy center were the first reason for the introduction of the so-called dark matter. The stars in the galaxy do not orbit the center of the galaxy according to Kepler's third law, which applies, for example, to bodies in our solar system. The speed of individual stars does not decrease with distance from the center of the galaxy, but is relatively constant. Keplers laws apply in system with most of the matter concentrated in the central body. For example, the Sun represents up to 99.86% of all matter in our solar system. But in spiral galaxies, not so much of the mass is concentrated in the center. The entire disk area of the galaxy also contains an enormous amount of matter to consider. And this effect is not negligible, even though the center of the galaxy may contain a greater concentration of matter than its arms. Therefore, a star moving in a galaxy's disk is not only attracted to the galaxy's center, just as planets are attracted to the Sun. It is also affected by matter from the outer parts of the galaxy, and it is this matter that accelerates the star on its way around the center of the galaxy. However, there is another factor that astronomers have not yet taken into account when observing galaxies and distant heavy objects. It is the gravitational dilation of time. Time dilation is observable either when you are moving very fast to the observer or when you are in a very strong gravitational field. And a large spiral galaxy certainly has enough gravity. What does this mean in practice? If the total gravitational effect towards the center of the galaxy increases, so will the dilation of time. And for a distant observer, the speed of objects closer to the center will seem slower than it actually is. However, some astronomers might immediately argue that the observed velocities are not lower, but just higher than expected. And here comes another interesting phenomenon that definitely needs to be taken into account in the observations. We must also take into account the gravitational field in which we, as observers, are now. Whether we are on the Earth's surface or in low Earth orbit, we are affected by the Earth's gravity. The Earth is affected by the gravity of the Sun. And the Sun, so as the entire solar system, is affected by the gravity of our Milky Way, which is also one of the large spiral galaxies. And this matter that surrounds us is certainly not negligible. All you have to do is look at the night sky somewhere outside the city on a clear night without a moonlight. Literally everything you will see with your eyes in the sky is matter in our galaxy. Therefore, if you look from the inside of strong gravitational field to the outside space, the movements of objects in a weaker gravitational field will seem to you much faster than in your immediate vicinity. Conversely, if you look from a weaker gravitational field to a stronger one, you will see that the objects in that field are moving slower than they should. And this difference is especially true for huge objects in deep space. And if you still lack some matter in our galaxy that could confirm that we don't need any dark matter, remember that at the end of its life, each big star will leave behind a supermassive neutron star or a black hole that is not very visible, but they are still incredibly heavy. How many such extremely heavy and invisible objects do you think are in the Milky Way and in our immediate vicinity? I think a lot, and that's why I don't think we need some fictional dark matter to explain the rotation of galaxies. If you still think that the strange rotation of galaxies is caused by dark matter, write me in the comments below why. Thank you for watching, and the next time I fly by the Earth, I will send you another new video from the world of space fiction.